Welcome to Cadalyst SmartCasts. In this episode, we explore how high-performance workstations and GPUs support the complex demands of AI-powered digital twins in AEC workflows.
Digital twins are already reshaping how AEC teams plan, manage, and maintain the built environment. From smart buildings to transportation systems, digital twins are complex, physics-based simulations that connect real-time data to models of physical assets, enabling teams to monitor conditions, anticipate issues, and simulate outcomes. This video, based on Cadalyst's editorial series developed in collaboration with Lenovo and NVIDIA, explores the technical demands of AI-powered digital twins and the infrastructure required to support them. A digital twin starts with a model, typically a BIM, GIS, or CAD-based representation of a structure or system. What makes it smart is its ability to simulate scenarios with physics-based variables and to connect to real-time operational data. That data comes from a growing range of sources: IoT sensors, cameras and scanners, weather and environmental feeds, energy and utility systems, SCADA and facilities management platforms. Once integrated, these inputs allow the digital twin to become interactive and predictive. Not just a mirror, but a tool to simulate future conditions, detect anomalies, and enable data-driven decisions. AI plays a central role to making that data usable. It surfaces patterns, forecasting outcomes, and in some cases, triggering automated responses. To support this level of complexity, AEC and infrastructure teams need robust data architectures built for continuous data flow, real-time analytics, and scalable AI workloads. Behind the scenes, the infrastructure must support computationally demanding simulation, streaming data pipelines, AI inference workloads, high-throughput storage and memory handling, visualization at enterprise scale. Compute performance directly influences how responsive and ultimately how effective your digital twin can be. AEC technology teams are adopting high-performance computing environments built for data-intensive, AI-enabled processes. Systems such as Lenovo ThinkStation and ThinkSystem workstations and servers, configured with NVIDIA RTX Pro GPUs, are well-suited for hybrid workflows that combine modeling, data processing, and AI inference. These platforms support efficient handling of large geospatial and BIM datasets, parallel GPU processing of simulation and reality capture workloads, GPU-accelerated tasks such as scan alignment, noise filtering, and registration, commonly powered by NVIDIA CUDA cores, AI inference for predictive maintenance, anomaly detection and forecasting, fusion of sensor streams from LiDAR scans and video feeds to control systems and field devices, real-time simulation and visualization for dashboards, system monitoring, and stakeholder engagement. New techniques like Gaussian splatting are also emerging for real-time rendering of high-resolution scene geometry, especially with scan-based inputs or point clouds, benefiting from high-throughput GPU environments. NVIDIA RTX GPUs, such as the Blackwell generation RTX Pro 6000, 5000, and 4000, integrate tensor cores to accelerate AI workloads by executing large numbers of parallel operations. This helps deliver real-time insights while maintaining system responsiveness. Together with Lenovo's workstation architecture featuring ECC memory, thermal stability, and ISV-certified performance, these systems offer a scalable foundation for technical teams managing digital twin environments. Digital twins are no longer isolated tools. They're integral to a broader system of predictive intelligence and operational insight. Current applications include predictive maintenance in HVAC, water and industrial systems, occupancy forecasting and energy optimization in large facilities, infrastructure health monitoring for bridges, tunnels, and rail networks, climate response modeling and emergency preparedness, scenario simulation for capital planning and system upgrades. Because these use cases span both real-time control systems and long-term planning, the underlying infrastructure must be flexible, scalable, and integrated with the organization's IT ecosystem. Performance requirements extend beyond speed. Security, uptime, GPU capacity, and platform interoperability are critical to reliability and resilience. Digital twins are rapidly becoming central to how AEC organizations understand, operate, and optimize the built environment. AI provides the predictive capability, while hardware infrastructure built for compute-intensive and data-rich workloads keeps them running reliably. For IT managers, BIM leaders, and technology officers, supporting digital twins means investing in high-throughput, GPU-accelerated systems that can manage today's complexity and scale to meet tomorrow's demands. To learn more, explore the full Cadalyst series on AI, digital twins, and infrastructure innovation at cadalyst.com/Lenovo NVIDIA AEC AI.
Thanks for watching Cadalyst SmartCasts. This webinar was produced in cooperation with Lenovo and NVIDIA. Find out more at lenovo.com and nvidia.com. Keep designing.